This lecture is introducing Venn diagram. Okay, what is Venn diagram? In fact, Venn diagram is a visual method to represent the functions, the variables, and how they interact with each other. So let's see some examples and let's see how does Venn diagram work. If we assume that here is the space of all variables, and in this space, so this one is space of entire variables, and inside this space we have a subspace which we can allocate it for a variable. I want to say inside the circle, the subspace is for variable x. Of course, the outside of the space we is x bar. So x is inside the subspace and x bar is outside of the subspace. Let's see another example. Here we will have two variables, one variable here and the other variable here. They have overlapped with each other. No matter what are the size of these circles, just it determines and it shows like in space. So no matter if it's small or big. The one of them is let's say is x, the other one is x bar. Now a question is that what is the space which is shared between these two variables? Of course, the red space is part of x variable and also part of y variable. So the red part of this space is x, y. So it is representing the AND gate. So AND gate is the common area between two variables. So any part of the space which is part of both x and y is AND space. So let's see another example. This time we want to see what is OR gate, OR function. For OR function, again we show two subspaces for two variables. So here is variable x and variable y, and we want to show x plus y. X plus y, what does it mean? It means that any part which is like which belongs to x or y or common area, both of them. So any part which is belongs to x, y, and like the common area is y, is all. So the green highlight area is OR gate. So let's see another example. Here in this example, we will have three variables. We have one variable here, one variable here, and another one here. Okay, now one of them is x, the other one is y and z, and we want to see what is the function of this space, like entire z and this area. So we want to write the function which is corresponding to this space. if you look to this figure, we see that any part of z is in the function. So is z, any part of z. So z plus, so and part of part of x and y, which is common between them, which is x and y, is also part of this function. So it's x, y. In fact, in fact, we divide this space to two spaces. So one is the green area, which is z, and the other one is this dashed, just these red lines, which is x and y. So if we combine these two spaces, we will have z plus y bar. The next example, again we have a space with three variables. Okay, and now one of them is x, the other one is y, and the last one is z, and we want to find the function for this region. Okay, so if we look to this green highlighted area carefully, we see that any part of x, any part of x, which is also part of y or z, is the function. So any part of x which is also part of y or z is the function. So one more time, I'm writing again. Any part of x which is also part of y or z is the function. Okay, so the last one is here. We have x, y, and z, x, y, and z, and we want to find this area. Okay. So we divide this space to two regions, and one of them is the common area between x and y, and the other one is the area which is part of z but not part of x. So we divided it to two areas. So let's write the function. The red part is the common area between x and y, which is of course x, y, or any part which is part of z but it's not part of x. So any part which is part of z but not part of x. Okay, so this one is the function. So one more time, for the red like highlighted area, we say any part which is for both x and y, which is x and y, plus for this part we say any part which is part of z but it is not part of X because you see this area is part of Z and X and it's not like highlighted. So this one is like the circuit. Okay, so this one was Venn diagram to representing the signals with visual format.